This video is proudly recorded and produced on OpenBSD. In one of my recent videos, I have talked about Unveil syscall, and in case that you haven't watched that video, the link is on the top right corner. I recommend you to watch that and then continue watching this video. In that video, I mentioned that Unveil and Pledge, they usually are used hand in hand. And Unveil functionality, just to recap quickly, is to limit the visibility access to the file system, meaning that you can say, okay, I don't want my program to have any sort of access to the file system, or I would like to have a limited access to the file system, and for example, shouldn't have the right access to a certain directories, etc. So you can do that with Unveil, and in that video I created a simple C program to demonstrate how to use Unveil in your code in case that you would like to code something under OpenBSD. In this video we shift our focus and we focus on the Pledge. Pledge, it's a bit more complicated than Unveil, but don't worry, we are going to talk about it, and we are going to also follow a similar pattern as we had in the Unveil video, meaning that do some coding in C. So let's begin with the definition of the pledge. So pledge is a syscall and is a security mechanism in OpenBSD that allows a process to restrict its own privileges and actions. And it means that, for example, your program will declare a set of promises, says that, hey, I promise to only access to X, Y, and Z and nothing else. However, if in the middle of the program or somewhere else in the program, it basically breaches its promise, then the program will abort with the sigabort signal. So the purpose of having this pledge in place is to reduce the potential attacking surface. It's only implemented when it comes to the mainstream operating system. It's only implemented in OpenBSD, but it's also on the more or less like a less well-known operating system. Serenity OS has also implemented Pledge and Unveil as well around 3 years ago. I will talk about that at the end of the video, plus providing you some references. Initially, the name of the Unveil pledge command was tame, and it was renamed to pledge around 2015. And the reasoning for it was, according to the OpenBSD creator Theo de Rat, was to make it like more kind of like easy to deal with when it comes to the conversation, technical conversations, etc. He explained it in this video, and I think also is a sexier name compared to tame. I think tame is a bit, at least to me, is a bit oddly sound. Nonetheless, Pledge initially appeared in OpenBSD 5.9, and it's older than Unveil. So when you use a pledge, this is the syntax, you should do it at the beginning of the program before your program does anything. It makes the program readable, and also if somebody looks at the program at the top of the program can know that, okay, what sort of the functionality this program would be involved in, roughly speaking. And also it doesn't make sense to run your program without any pledge and then afterwards in the middle of it do pledge. I guess it might be better than nothing, but to me it doesn't sound very logical. Mind you that once you call the pledge function and you pass a set of promises, you cannot lift those restrictions anymore. You can restrict it further, but you cannot lift those. Let's say you said that, okay, I would like to just access to the standard input output, to the keyboard and to the monitor, etc. If you set that promise at the beginning of your program, and then later on you remember, hey, I need to read the file under I don't know, user home directory, then you cannot basically revert that. You cannot say, hey, you know what, I have forgotten something. You need to basically rewrite your code, set the promise at the beginning. So that's how Pledge works. It's similar to the Unveil. In the Unveil video, I made a mistake that I said that at the end of the program you need to set the Unveil to null. That's obviously not needed, and I made a mistake, as a viewer has corrected me there in the comment section. So what sort of promises we have? So when it comes to the promises, this is the list of the promises, and you have a standard input output, read access to the file system, write access, etc., and the list goes on, and you can guess it. And also we have something for the exec, etc. So we have, for the pledge, we have two arguments. One is a list of the promises, and the second one, which is a bit ambiguous and unclear, especially if you haven't dealt with it, is called exec promises. And this one is used when in your program you call exec syscall, meaning that you spawn, simply put, you spawn another program within your program, right? Then you can even pledge that program that you execute from your program. We are going to demonstrate that as well, so you get a very good understanding about how to use promises and exec promises. Enough of talking, let's now go to the coding part, which is more exciting. So I'm going to create a simple program called pledge.c. I start by just coding a conventional hello world in C. So stdio.h, int main, int argc, and then what we have character argv. And note actually here about my C, let's say, competency, or more or less like a kind of like a disclaimer to you. I am an amateur C developer. I'm not professional at it, and I code C in an old-fashioned, or a bit more by today's standard, unconventional way. And even the way that I format the code is a bit outdated by today's standard. So take my C code example with a grain of salt and apply the best practices to it. Of course, the main of this video is not about how to write the proper code in C. It's about how to demonstrate the use of the OpenBSD security feature when somebody codes. That's about it. So what we do, we say, okay, put s, it's better than using printf. Thanks somebody in the comments for noting last time. So we just say hello, and then we do return 0 here, and if we compile the code, it will just print hello, right? So this is a basic, super basic program here. So in case that we want to pledge this program, we have to actually use the unistd.h, because that's where the pledge code resides. So then we can call the pledge function, and it accepts two arguments. So first one, we can actually pass null, and then we can pass null. So if we pass null means that our pledge has no effect at all. So then the program should work still, and as you can, and I haven't run it, and as you can see, it works, right? Now let's say we want to actually implement or enforce the proper promises in our program. So we say, let's say wrongly, we say, okay, my program just needs the read-only access to the file system, right? And similar to Unveil, Pledge returns an int when you call or invoke the function. So we have to inspect that, and in case that it went unsuccessful, then basically exit the program. So if it's successful, it returns 0. If it's unsuccessful, it returns -1 to what I remember on top of my head. And in case that we got the -1, what we can say, okay, P error, failed to enable pledge, and then we exit from the program with 1 indicating that the program terminated unsuccessfully. Now if we compile the code, we got abort trap or sig abort that is stated in the documentation. Why? Because our C program requires to have access to the standard input output. So if we remove this and instead we say stdio and compile the program, you can see it works. What if we want to pass a list of the promises that the program needs? Meaning that, let's say, hypothetically speaking, the program not only needs to have access to the standard input output, but also it needs to have access to the file system, read-only access. So in that case, we can just pass the list of the promises space separated. And if we compile the code, it works, and we do not get any warning that, hey, you haven't used the rpath pledge at all. We don't get any warning for it, and that's fine. You just need to make sure that you don't request too much things in case that you don't need it. So this is about the basic, very basic, simple pledge functionality. Now let's talk about the second argument, which here we pass null or nothing. And as I mentioned, this one is used when we are going to basically call the exec syscalls. So when it comes to the exec syscall, we can actually pledge that syscall program that we invoke. And this is a can, but I would say you should, because it's a safer practice. So for that one, let's actually invoke a cat command on this pledge file. So we would like to do cat pledge, this one, right? This is what we want. So what's the syntax of the exec? We can say exec v whatever, and this is the syntax that we get for a C. So as you can see, it resides in the unistdh, so same header file as pledge and unveil, and it has many functions with different things, but essentially what all these do, allow you to invoke another program. And what we want to do, we want to call the cat command from within our program and open and basically cat out the pledge file that we are writing right now. And the simplest one, to my estimation, is the exec v. What we can do, we can pass the full path of the command and a list of the arguments in forms of array. And it has, as I said, it has different syntax. You can also pass the list of the environment variables, etc., etc. So let's quickly just put this one here. So exec v, and we are interested to call the cat. So the cat full path we need to pass, and that resides in the /bin. And then we need to pass the list of the arguments here. So for that one, we say char args. So we define an array. The first element of it should be the full path of the program. Again, there's a bit of the redundancy here, and that's because most of the programs, they expect the first argument to be the program name itself. And then afterwards, we can pass the actual argument to the cat command, which would be my home directory, and then the name of the program, pledge.c. We would like to output this syntax. And lastly, what we gotta do, we gotta terminate this one, so we can say null to signal it that we have no longer anything here. And I need to put a semicolon here, and then we can pass this one like this. Let's try to run this one, see what happens. It should technically work. And okay, we got abort strap. Why? So we have forgotten to actually say that our main program also would like to use the exec syscall. So once we get the access to the exec syscalls, or we pledge for it, then it works. So now what we did, we invoke the exec or the cat command from our program, right? Something to note here is that the moment that the exec or exec syscall runs successfully, the rest of this program doesn't execute. However, if the exec syscall fails, this program continues to run, or the rest of the program will be run. So for that one, what we can say p error failed to invoke the touch command, in case that the touch command has failed, and then instead of the return 0 as in the conventional programs, we have to return 1 because the exec syscall has failed. This is a bit weird, but because we don't use a mechanism to spawn properly here and to fork it, then this is what happens. To tackle it properly, we need to actually call the fork function and then afterwards get the, I think, PID, etc., and then do the proper things, but that will make our program much complicated, and then we don't want to go through each of lines of those codes and explain it. So I did it a bit of a cowboy way per se. So, and if we run the code again, just for the sake of making sure that it works, so it works. So now this cat command is not pledged, right? And as I mentioned, the second argument here allows you, which you should use it if you are planning to run the exec syscall in your code, to actually set the promises for this whatever program that you're going to spawn, right? So in this case would be our cat command, and if we look into the cat functionality, what we have access, read access to the file system, plus we have actually output to the standard out, right? So what we need to ask for, we have to ask for stdio and rpath, and if we do that, then the program should work. Right now our cat or our external program is also pledged here. If you run it alone, it's not pledged, but since we wrapped it, it's pledged also, right? So meaning that if the program wants access to some other crap, then it's not gonna work. So this is what we have. So what if we actually remove the rpath? Let's see what's going to happen. So if we run it, we get the operation not permitted. Similar error we get if we try to actually cat a file that we have no read permission for it, and that's because we actually removed the rpath. And if we actually remove the stdio, what we get? We should get actually sig abort, and as you can see, we get abort because it cannot actually output the file contents to the standard input output, right? So as you can see, the above program works. So this pledge has absolutely nothing to do with the cat, because for the cat we actually apply this pledge to it, right? And if we look into the cat source code itself under OpenBSD, we can see actually the cat source code uses stdio and rpath. And since cat command is not going to call actually exec syscall, then this one is null. And in case that you're curious how to basically properly format your code, your C code that is compliant with the OpenBSD, this is how they do it. Again, my code is not compliant with the OpenBSD formatting. So this is how we use basically we spawn we spawn a command or a program, and then we actually pledge it. Of course, what we are doing here is redundant because this cat command is already pledged. Matter of fact, all the programs, every commands, whatever that you have in the base system is already pledged Unveil if it's necessary. And also things in the port system, most stuff are also pledged. Some of them, not all of them I think, but I think most of them. For example, Firefox definitely is pledged and also is unveiled. Chrome I'm sure is unveiled, but I'm not sure whether it's pledged or no. So but if you, let's say, have a program that you don't know it's pledged or unveiled or whatever, and then you can basically somehow a bit trick it, make it a bit safer like this, right? So this is what we have here. Okay, now let's actually extend this example and use both pledge and unveil together and see how it will work. So if we look into the pledge man page, we will see that one of the promises is called unveil. Here it says allows unveil to be called, and meaning that if we want to use the unveil in our program that is pledged, we need to actually ask for it. So for the sake of this example, we are going to say, okay, my program is going to use unveil, and let's actually make things a bit simple. Let's get rid of the exec syscall here, and I'm going to delete these codes, we don't need it, and instead here we'll be returning 0. So we want to combine both pledge and unveil together. So when it comes to the unveil, we need to actually clear it or ask for a promise on the pledge side, and then we need to call the unveil command. So it will be similar to the pledge. So unveil, first we need to pass the path. So what I'm planning to do is to create a test file under my home directory and basically write something to it. So I call it, this is my home directory, and I call it unveil.txt. And what will be the permission for this unveil? For our case would be creating of it and then basically writing to it, right? So it will be W and then would be C. So W and C. And if it became -1, meaning that our unveil has failed, so we are going to PR that failed to enable unveil, and then return 1. So right now what we are going to do, we are going to actually create a file with the fopen in the C. So file, this would be the pointer, file pointer, fopen, and then /home, my username, and then I call it unveil.txt. I made the mistake somewhere because I had to specify the path, not the file name. So here I'm going to remove this. This is the path. So the program has a full write and create access to my home directory. And here we are going to create the actual file in the program. And we have to do check that if the file pointer is null, meaning that we failed to open the file for whatever reason, such as permission denied, and failed to open the file, and then we do return 1 here. And now we are going to write something to the file. So fprintf, so file pointer, and then we say that this is a demo of pledge plus unveil, and then we are going to close the file pointer. So Alright, now let's try to run the programs and see what happens. So if we do pledge and then we run it, we got abort trap. Why that's the case? Well, I played around prior to this video a bit to understand the reasoning, and the reasoning for it is that because we ask for the unveil promise, but yet for this program we haven't asked for the promise to the file system at all. So meaning that unveil on itself without access to the file system through the pledge is pretty much useless. So first we need to get access to the file system via pledge, or get the promise of it. Right now we promise that we don't use file system, and then suddenly we actually call the unveil, and then that's why the program fails. So we have to do that, and then in the unveil we have more granular access, because in the pledge we cannot say that, okay, I would like to have access only to this particular path of the file system. Pledge is not designed for it. Pledge is designed for a higher level, meaning that I would like to have read access to the file system, I would like to have write access to the file system, I would like to have create access to the file system, etc. And then it's a responsibility of the unveil syscall to further narrow down the access to the file system, meaning that unveil should say, okay, this program has access to the file system, let's say read access to the file system, but does it supposed to have access to the entire, read access to the entire file system? We say no, of course not. It's supposed to only have, for example, access to the users directory, read access to the user directory. Then it comes to play of unveil. So here we used what? We used write and we used create. So now if we look into the pledge, what we gotta do, we gotta actually add wpath and cpath. So wpath is a set of the allows to have access to the set of the system calls that actually effectively has write to the file system, and cpath is for creating to the file system, right? Whether it's a file or a new directory. So we say cpath and then wpath, and then let's see what happens. The program should work right now, and if we do unveil text, you can see we have it, right? So let me remove this one, and then for example we are going to delete write path. Let's see what happens. So we got the abort trap. Do we have the file? No, we don't have. So in case that we want to have access, we want to call the unveil after pledge, which we should do as the documentation signals us through unveil promise, then we need to specify whatever things that the unveil would actually like to allow here as well. So I cannot say, okay, I'm not going to allow cpath, but here in my unveil I expect to create something to the file system, and vice versa for W. So pretty much this and these two should be a bit in sync. Of course, if your program is complicated, and then which means that you are going to call unveil multiple times, then no, you just need to get a higher overview of it and have a better understanding of what your program exactly is supposed to actually do when it comes to the file system changes and access to the file system. Before ending this video, in case that you would like to know more about pledge and unveil, first of all, I highly recommend you to read through the pledge and unveil man pages. That's for the beginning. If you didn't understand it, or you find the jargons a bit like too technical, and yet still you are interested, you can read this blog post by Andreas. He is the creator of the Serenity OS, and he described this pledge and unveil in a very simplistic manner. It's very understandable. Of course, it's a bit specific to the Serenity operating system. And even if you would like to understand how it's implemented in the Serenity operating system, there is a full video of him actually implementing the pledge in his OS. Besides that, there is this presentation by Bob Beck available on the OpenBSD website, and he actually explains about the pledge and Unveil. Finally, there's this video by Theodoret explaining the pledge technology. That's all for this video. I hope you have enjoyed it. I would like to take a moment to thank Patreon contributors: Grog with $30 generous, Stellar Orbit with $20 generous, Inlakesh with 10 generous euro, OpenBSD Maximalist, Alexander M, Bogart Hackscock, Monty, Russell Willis, and Seneca, OpenBSD Enthusiast, DM'd and Liquid Mobius, and finally OpenBSD Curious, Ryan Woodford. Thank you guys for your contributions.